We're live.
All right, welcome back and welcome to this session where we're going to discuss the ins and outs of explainable AI. My name is Axel Ngonga. I'm a professor for data science at Paderborn University. I deal mainly with knowledge graphs and how we can use them to actually power intelligent data-driven systems.
Hello, everyone. My name is Caglar Demir. I'm a co-founder and CTO of Tentris and a senior researcher at the data science group of Paderborn University. My main motivation, daily motivation, basically, why I wake up every single day and try to design techniques that basically leverage knowledge graphs and tackle fundamental problems for our society. That will be all from my side.
All right. Thank you, Caglar. My name is Dean Allemang. I'm a principal solution architect at data.world and author of semantic-web for the working ontologist. I've been doing semantics and AI for my whole career, and in the past year or so, things have taken off where we are accomplishing things that we never thought we would see in our lifetime. And so I'm really interested in understanding how we can apply this to really change the world. And so this is why I've come here to share all of these things with the audience here at Swarm.
Thank you. My name is Joaquin Melara, and I'm the founder of the Swarm community. Swarm is actually an acronym that stands for Sentient Wisdom and Artificial Reasoning Machines. And the purpose of bringing together Swarm and having a community is to exemplify the spectrum of technologies that fall under the umbrella of artificial intelligence. I think that the term itself has been abused enough by marketing departments around the world, and we can only do justice by bringing industry practitioners to talk about what they do. So,
cool. Well, let's kick off this discussion. We've basically talked a lot about knowledge graphs, artificial intelligence, and so on and so forth. And one topic which is pretty hyped at the moment is actually GraphRag. So retrieval augmented generation on the one hand, using graphs on the other hand. So from your perspective, what is GraphRag? Maybe we can have Demir start.
Sure. I guess if you take a look at the last few months, GraphRag or RAG has been taking over basically the research as well as the AI-based applications. And if you take a look at the word in itself, like retrieval augmented generation, and which hasn't specified the input data, basically what to retrieve and what to generate. So generate part perhaps is LLM basically, but mostly we focus on text data, textual data. The GraphRag part, there are plenty of different techniques applied under the umbrella term GraphRag. So for some, GraphRag corresponds to the Microsoft's recent paper, basically giving a text data, you create a RDF, you create a graph, not RDF graph, you create a graph for the text, and then you perform a retrieval operation on that particular process data. For some of us, like me, myself, I understand the RDF knowledge graph. So we have a background knowledge which has the T-box and I-box axioms, and we would like to design a technique that allow users to ask natural language questions and return back, generate results that are based on the facts that encoded in the input knowledge graph.
So, credit where credit is due. The question is from Dean. So, Dean, would you be satisfied with that answer?
Yeah, so actually I wanted to follow up on it a bit. I tried to install IBM's GraphRag stuff a couple of months ago, and since I don't have an Azure installation, I've never used Azure before, I literally spent 2 days trying to install it. I think I could have reinvented the work in the amount of time that I spent trying to install that software. I think I would have preferred if they had just outlined the algorithm and give it to an LLM and have it coded up again for me. But because I really I could not figure out how to install this into the Azure stack, because first of all I had to get it anyway. So but when I think about the sort of RAG that we're doing, and so for those of you who didn't see my talk about an hour ago, one of the things we're doing at data.world is a chat with your data sort of situation where a question comes in and we want to generate a query against a knowledge graph. And part of the issue there is that the ontology that describes the knowledge graph is very large. And usually they're not very large, but they're large enough. You want to figure out which bits to bring in. So this seems like a job for RAG. Now, when I hear about my knowledge graph is already in a graph and I want to do RAG, it seems like graph RAG ought to be what I do. But what we're doing is something I'm not sure if this counts as graph RAG. I want to kind of dig into this, and that is for every class, every property, every data type property, every object property, we actually generate a little chunk of text, a little piece of document. And then we do standard text RAG over that stuff. And then so we bring the question in compared to that stuff and say, oh, this class looks good. This class looks good. That property looks good. And we do some more stuff where we take the connectivity, because there's not much point in bringing in an object property if you haven't brought in both its domain and range, presuming you're doing domains and ranges. So we do that kind of stuff and we're all done. We now have a list of things and we just do a describe query about those. So I'm using the graph a lot, but I'm not actually using it in the retrieval. I'm using it in the construction of the, I'm using the augmentation. I'm not using graph in the R, but I am in the A. And so when I look at this, I think, well, am I already doing very sophisticated graph RAG, or am I just doing very roundabout document RAG? And so this is where I don't quite understand when we talk about graph RAG and the details. Well, I guess here's my question to you, Caglar, that what I just described, am I doing graph RAG?
I mean, I would say it depends, because the techniques we applied requires that your properties carry some syntactic information. For example, I mean, if I understand correctly, if the data properties that you mentioned, if you have a bunch, the URIs in itself doesn't have to carry semantic meanings in the syntactic representations. And if your URI consists of a bunch of numbers,
then it won't. But it's not just the URI. We built a little document out of it by looking at its label, its pref label, if that's relevant, its domain. You're talking about a data type property, so its domain is certainly there. Its range might not even exist, but it might be there as a string or as an XSD thing. So one of the ways I, as a user of the system, can tune it is actually change the formula for building that little text signature. That's done with a Sparkle query, of course, and it just builds up a little text signature. So the text signature can take the URI, but anything else that the solution architect, want to put in. So there's a couple of stages there. So what the system does, what the solution architect does, and then what the end user does. So this is actually an affordance for the solution architect to be able to say, here's how I will help you decide that, and that's a Sparkle query. So I can use any aspect of the graph that I choose, or that I'm competent in Sparkle to write. Typically, that's a very simple query, but it needn't be.
Well, I mean, it seems like, so if you look at the different survey papers that swam around, I mean, there have been a few since 2022 on what RAG really is and the different RAG architectures. It turns out that we've not completely defined, at least to my understanding, what graph RAG is. We basically say there is going to be a graph there somewhere, but we don't really say it has to be really one of the sources upon which the retriever really operates. So I would say, yes, you're doing graph RAG, but it's one graph RAG flavor, and there are plenty of them out there.
And I think that's the interesting thing with, I'm actually building a string, and that's what we build the embeddings from. I'm not building an embedding from the graph. I'm making a string, and that becomes my embedding seed. And so it looks like I'm basically doing text RAG of bits of a graph. You could imagine taking the graph itself and take that through the embedder. And so it's the graph that you are making the embedding integer or embedding vectors out of. And if you say graph RAG has to be that you're actually giving the graph to the trainer, then I'm not doing graph RAG. If you're saying graph RAG means you're able to find any part of the graph as you do your RAG, then I am doing graph RAG.
That is indeed correct. Whereas the question is basically what would be the pros and cons of the different architectures. And so, sorry, Joaquin, just a little bit on that. And it seems to me that actually using the text, basically flattening the graph into a bunch of text documents.
Basically, that's exactly what it does.
It has the major advantage that you can reuse a lot of components of a standard RAG system.
But and that's why we did it, right? Because we just bring a RAG basically out of the box.
But I think the major challenge or major problem with that is that you actually lose the structure information. So if you think about path queries, for example, or using a cleaning operator or something on the graph, that becomes really, really difficult.
But by the time you get the augmentation, the augmentation is the graph again. So you're only using that for your embedding. once you say, oh, I want this class, this property, and so on, what you actually put into the augmentation is the graph. So you get that back.
Well, you get parts of it, but if you imagine having to run a Spark query where you have a clean star on the property. So basically looking at all property chains, you would basically have to have all of the documents which contain that type of information really in returned by your retriever, and that really ever happens because they usually return a small number of documents. That's the one.
Remember, we're talking about an ontology here, so that cleaning star will almost certainly be either on subproperty or subclass. You're not going to use it on anything else. Those are the only properties that you do cleaning stars on, actually in practice, against an ontology. Against the data, you might do anything, but against the ontology, in fact, in OWL, those are the only two words that you could do it on. So what's the number you're going to get? However deep your class structure is, no one makes a class structure deeper than 10. FIBO, I think, has 10 as its deepest thing, and FIBO is the biggest ontology I can think of out there.
So if you think about the DAP paper that looked at the yottabyte problem with cleaning stars, I would think that that's not necessarily the case, that you would only end up with 10. You can end up with way more, especially if you use non-distinct.
Not in an OWL ontology. Not in an OWL ontology. You're not going to say, look at the National Cancer Institute ontology. You've got female as a subclass of human, as a subclass of genus Homo, as a subclass of primate, as a subclass of stuff. That goes about 15. I mean,
so you're basically just looking at the T box here.
Yeah,
not at the A box.
Yeah, that's what I said. I'm talking about the ontology.
Okay, if you're just looking at the T box,
data, you're absolutely right. You go heaven knows how far, but in the T box.
Okay,
I didn't want to
you only do that at T box level. That's fine. Yeah. So if you're doing a T box level, absolutely concur. But in general, what we're interested in basically at Hendrix is mostly the A box. So that's basically where people try to retrieve a bunch of value and then it goes nuts. And the main advantage of basically going beyond flattening is exactly that you basically have these long paths that you can retrieve, which are a bit more tedious to get a grip on.
Yeah, because you wouldn't be able to get a meaningful flattening of something. Like I suppose you're using just ordinary family tree. That's a good example where you could easily go back as many generations as you like. And if you actually want to get your family name, which is all of your patronymics going, and matronymics, as we have both patronymics and matronymics going back, even the 10 generations would be a ridiculous.
In your face, absolutely.
It would be a jumble of mush. And
that's a fantastic example, exactly that. And that it becomes rather interesting to actually say, let's keep the graph structure going and actually try to either generate the data at runtime and basically say, this person wants a clean star. Yikes. Okay, let's generate that and shove that into one document, which is an index, or basically do parts of the query in a multimodal way. So a discussion I had with Damien, I think it was 2 days ago, was actually, can we go beyond Sparkle and actually make it do the RAG part? So integrate RAG components directly into a Sparkle engine, because that would actually make things so much easier. And those type of, let's say, star in an A box could basically be shoved directly into the Sparkle query. So that's I think it has a lot of potential. But to answer your question, I don't think there's a one sums it all type definition of graph RAG. So you are doing graph RAG, a particular flavor of it for sure.
Okay.
I think it boils down to information retrieval with the added benefit of using LLMs as a interface. But the chaining effect of how you're retrieving that information, whether you're interfacing with a database, whether you're interfacing with an LLM or a knowledge graph, or in which order, that is up for the architect's design choices. And even the description of RAG has so many different permutations, whether you're using vector databases or whether you're using ontologies. So there's no unified definition outside of we're retrieving information in natural language, and enriching it with a way to ground it to facts, right?
So do we think that RAG is the future then? I know I'm moving away from the script here, but why is RAG so good? Or is it really good?
Well, I think you often hear this mantra that attention is everything, and in some sense, RAG is a way that we get to control attention. By we, I mean the human beings who are setting up this system, and it's kind of crude, but nevertheless very effective. And I think that's where a lot of its effectiveness comes from, is that we get to adjust the LLM's attention.
Oh, that's a really cool take. Damien, what do you think?
I mean, as a maybe engineer by heart, what I'm thinking following. There are plenty of large language models. If you got Hugging Face, you have a leaderboard. Every single day, almost ranks are somehow moving. Top 20 always changing. Top 3 maybe, depending on the task, obviously. As a developer right now, I have a laptop. Let's say I have a beautiful GPU that I can fit something there. How can I use this weight matrices, a large language model, on the data that I'm currently having on my local machine? I mean, the next answer is fine-tuning, but no. So fine-tuning, it's not a means for everyone's disposal. So to fine-tune, you need hardware, you need data points, etc. However, if you have the rack basically platform, so get the data, chunk it in some document level that you decided, and then use default embeddings, basically text embeddings, to map your question to the vector space, find the most similar ones. That's basically half an hour work.
Yeah. As opposed to training, which would need a GPU much more powerful than the one that you and I have sitting on our home offices, and a lot more time. And if it doesn't work, oh my God, you just spent 2 days training. You have to try it all again.
Absolutely. And what is the learning rate? So which part to be freezed? Because you cannot afford to put in an all model single GPU. Like even if you take a look at the 70B model, decrease the quantization to 4, so it doesn't fit. So, but however, I can basically do disk-based GPU CPU offloading, and for the one forward pass, I can manage to wait like 5 seconds.
Yeah.
So that's basically my way of looking at the.
And I couldn't agree with you more. I think we're kind of saying the same thing, right? You have a way of adjusting what the LLM is doing, but the fast turnaround is what you're emphasizing here, and that you're not going to be able to do development if by development you mean a 2-hour turnaround every time you do an experiment.
Absolutely. Cool. I mean, that's my flavor.
I get it. Yeah.
So please.
I think you're both addressing part of the equation. Accessibility to the technology is what's making it so popular. If it wasn't so easy to just download LangChain and use an open API key to construct something in 30 minutes, it wouldn't be going so crazy in the marketplace, and it wouldn't be driving that hype. Knowledge graphs have been in academia since the 70s, and even before then, theoretically, they've been around for a very long time. But the accessibility to the theory and the tooling, it's not quite there. But it's coming around with this.
Well, you know, Joaquin, I'm going to challenge that. About 6 years ago, I was at a conference, no longer, probably more closer to 10, and there was a fellow who was from a potential customer of all the folks at the conference, and he said, the reason that Neo took off and the semantic web didn't is how easy it is to download the community edition of Neo and just get started on your laptop right away. So first of all, Neo was doing that successfully. Actually, it was more than 10 years ago. That's when he said this. Now, I found this rather odd because if you go back to 2001, you could download Jenna onto your laptop. You did not need to buy a GPU and run that. And even back in 2000, there was this little company called IntelliDimension. They were and I always said in those days, they were the quickest way to hello semantic world. That was a Windows only, click on a button, install. Your Windows came up and said, permission? Yes. 2 minutes later, you've got a triple store running. It had a web server inside of it. You could write an HTML page that had a little thing that says escape query. If this was actually almost as easy as going to ChatGPT, not even what you just said, downloading LangChain. Well, did you just say download and install? Okay, that's about where they were. That was 2000. It was 24 years ago. We've actually had this forever, and it's been as easy. I'm afraid, Joaquin, that's easier than LangChain. You really was just, yes, please finish the install. And then when you're in that web browser, a web server, it was exactly as if you had downloaded Apache. It had configured the same way, nothing different. So the tooling is not the bottleneck here. That was available 25 years ago.
My response to that is the technology may have been accessible to download and use, but it's also the commercial aspects that drive the conversation forward. And Neo4j spent a ton of their money, a ton of their revenue in driving marketing to sort of sell this as a cure-all.
Absolutely. Yeah, marketing is a huge part of this, and that's what didn't happen with IntelliDimension. You know, you've never even heard of them. Jenna was an open source project. Open source projects don't market unless they get a company like Neo that's created around them as a marketing company to make that happen. It's not the technology that does it; it's the marketing. And then so it's not a matter of the availability of the tooling that was there. What was not there was the marketing. It made people say, "Ooh, hype! I want to try this." You know, why have I downloaded Llama, and why did I buy a GPU? You know, I'm not a gamer. Why did I buy a GPU? Because all of this cool stuff, but also ChatGPT was even easier. That's a zero download. You know, you just go there and you start typing in. And no, data.world, the thing that attracted me to data.world 10 years ago is it's also zero download. Take a spreadsheet, drop it on the data.world, start writing SQL or Sparkle queries. You've installed zip, zero, nothing, nada. You're running right away. If you have a LinkedIn account or a GitHub account or anything, you don't even need to form an account. The entry barrier is so low, but no one's really excited about writing queries over data. And even people who are, actually, they don't trust that. They go, wait a minute, you're going to host my data? Yeah, we host all of the smart city data for the city of Louisville. For free? Yeah. We're not hosting any more than GitHub. You know, and GitHub by company, but even when GitHub was its own thing, it's like, no, it's not like we're hosting enormous amounts of stuff. We're just doing what GitHub did, but we're doing it for data. I can't believe that. It must not be true. Go do it. But they don't, because they just can't believe that it's true. And so that's actually a zero download, but ChatGPT is even better. You just start typing stuff in English. I mean, you cannot beat that. That's actually even better than Google.
There's two questions coming in from Alexander. Alexander reads, I am wondering, how do we resolve entity linking across a variety of RDF and non-RDF data sources in large companies? And then he corrected the second sentence. And how can we guarantee not to leak info that should not be shown to a user not having proper access? Yeah. So that's a can of worms, I think. But
it's a hot topic. I have seen 2 talks in the past week that address aspects of that, and I'll talk about them. I think Caglar had something. It looks like
no, please, I want to hear.
Okay, yeah. So for the second, well, I'm going to do the first one, I guess. Can you put those back up in front of me again?
Let's start with the first one.
Yeah. So entity linking, and this is a hard problem, and it's not actually any easier now than it was. This is a problem we've had before. This problem was here before we had LLMs. This problem isn't even a knowledge graph problem. Knowledge graphs just give you a lot more ability to exploit the connections once you have them. But relational databases and websites have had this problem forever. But I actually saw a talk here at the International Semantic-Web Conference yesterday, where somebody is addressing this in a way that I haven't seen before. That is, and he's specifically talking about if you have blank nodes in 2 different data sets. Now, you're talking more generally in your question, but yesterday's talk was how do you determine when these 2 blank nodes are talking about the same thing? And he actually did something that looks a lot like GraphRag. He took a little graph cloud around these things and then made an embedding from them, GraphRag style, and then does this, and he was talking about terabytes of data, and do this through your whole world. And then inside of your vector embeddings, do from here on out, the story's familiar, find your nearest neighbors. He had a little algorithm that was sort of like a ranked choice voting thing to figure out who would go together. And the details of that algorithm, you have to look at his paper. And then he comes out and he now has a whole bunch of matches and the confidences you have in those match. And it's all using the sort of stuff that we know from vector databases. But it's almost like he's using GraphRag to approach this problem by looking at the little bits of relevant graph, for making embeddings out of them, and then doing the usual nearest neighbor.
You're talking about the Blink paper, right?
Yeah, I am. Yeah, that's right. This is your guy. Yeah. What's his name? I've forgotten his name.
Mohammed Sharif.
Yeah. So I saw his talk yesterday. It was very interesting. Now, for the second half of the question, though, this is the one that I was really excited about. 2 weeks ago, the EDM Council has a special interest group on AI, and we had a guest speaker whose name I really had better find so I can give you her name, because she connected me on LinkedIn, so I should be able to find it quickly. But I had not met her before. But she had this amazing thing that application I never thought about. When you do an embedding, so you take, say, a chunk of graph or text or whatever, and you embed it, that embedding is typically information destroying. Now, you can't actually reverse it. You could make it so that it's not, but you can also make it so that it is. If you take that embedding and you train your models to work on that embedding, anybody who spies on your model is going to see vectors of incomprehensible numbers. And if they pull one of the vectors out that happens to be meaningful, they can't reverse it. It's gobbledygook that I shouldn't say the LLM, that the neural network understands, in inverted commas there. And it can do whatever processing it's doing, finding connections, finding nearest neighbors, and so on. And when it's all done, it says, here's your nearest neighbor, and it's another incomprehensible vector. If somebody is spying, they can't make heads or tails of this. The only people who can make heads or tails of it are the ones who did that embedding to begin with, and that they can keep behind closed doors. So you've got the thing that may be vulnerable to leaks is talking in a language that is so gobbled. It's actually information destroying language, so you couldn't possibly reverse it. But the folks who actually put it in there. So the use case that I came up with at the end of her talk was, let's suppose we have two pharma companies. There's some metabolic pathway that, say, produces insulin, or maybe processes. Yeah, let's say produces insulin. I've got a drug that will help the first half of this pathway, and you've got a drug that will help the second half of the pathway, and the patients we're worried about have a complete breakdown of the whole pathway. If you and I collaborate, we solve this problem. I am not going to show you my drug, and I'm not going to tell you what pathways I'm working on. No way. And you're not going to show me your drug and tell me what pathways you're working on. No way. But if we put them into a neural network that is looking at this matchmaking, it finds the matches. If it finds no match, well, you've got a gobbledygook vector of my drug, useless to you. I've got a gobbledygook vector of your drug, useless to me. If the neural network finds the connection, it'll say, you two need to talk. Together, you've got a miracle drug. Here's what you need to look at. So this is these sorts of scenarios. As far as I know, this is not actually implemented, but it's implemented in sort of proof of concept. But I think this approach is really very interesting, and I will have to look up her name and for anyone who's watching this, so we can put it into the notes. There's some really interesting stuff that like applications of this, and they are really addressing or being motivated by, I should say, that second point that Alexander makes here, that you want to be able to do your processing on these entities without tipping your hand if there's any sensitive information inside of them. And I guess a huge issue. And I think that the neural embeddings are a really strong approach to taking care of this.
So we looked into this when we built embeddings.cc, because we basically got the idea of, hey, there's so much data out there, but processing the data is hard, and the GPUs are expensive, and some people don't have them. So why don't we actually throw the data out there and basically embed a bunch of data sets, make the embeddings available so that people can actually run on the embeddings without having to process them. Mm-hmm. It turns out that it is a highly non-trivial problem to do that match. So we looked basically into different techniques to do so. You can basically assume you're living on the hypersphere and then use rotations and translations, so the classical Procrustes type algorithm, or you can assume that you have some manifolds that you need to reshape and so on. It becomes really tricky. But I do concur that if the manifolds are actually comparable, assuming that you live on some manifold, if they are comparable in some sense, in the sense of having potentially the same number of dimensions and actually living in the same, we get really technical here, so basically expressing the same type of Clifford algebra, then that is a powerful way to do things. But there's still a bit of agreement that the two parties need to have. But basically,
absolutely,
we're gonna embed. I don't know.
I'm pretty sure that her whole thing is based on the idea of a marketplace where all the parties are agreeing on those embeddings, so that they can do that. And that's why I think my use case is one that's actually quite realistic, because the pharma companies really do wish that they could find these synergistic things, and they expect that there probably are a lot of them, but there's sort of no way in a competitive landscape to find that out without tipping your hand and damaging other parts of your business.
There've also been a few European efforts on that, right? So this whole idea of what do they call them? Controlled information data spaces, I think, for
You know, and OpenFacts was a very early effort to do this, but OpenFacts would only work on the open data because
sure.
of the problem. And so what I really see is that the vision that OpenFacts had, which is this sort of marketplace of data where there's an awful, in pharma, it's pretty, there's actually a reasonable vision. An awful lot of that data is morally and ethically open data, and often legally as well. So manage that open stuff, but have your platform allow you to put your own thing in. But that doesn't solve the problem that I described of the synergistic capabilities between two of the partners. And that's the thing that OpenFacts was never really able to do. We have open data that I can use for my research, that same open data you use for your research. But if we ever want to find that collaboration, we're still in the same position that we don't want to tip our hands. I don't even want you to see what queries I'm running. Yeah, it was a really difficult problem. And I really think that this embedding, but you're right, you need to have a whole marketplace where the embedding is something that everybody agrees on, but the processing inside is opaque.
Well, one question.
Isn't that what Gaia X, for example, does? So I'm not saying I love the embedding idea, don't get me wrong. Yeah. And I really like the fact that we can actually predict things that were not originally in the data. That's really one of the beauties of using embeddings, right? We can say it's close enough, even if it's not the same thing. So that's pretty cool. But there are basically things like Gaia X and so on in the European Commission, which have tried to do that, but not at embedding level. And I would love to see how that would look like.
Yeah, I would too. I think it's a really exciting idea. And I will look up her name and supply that. And we'll put it into the notes here. And I think I hope that she's glad that I've promoted her work in a completely different venue. And hopefully we can find some interesting connections.
So, Joaquin, I didn't want to interrupt.
Yeah, Caglar, can you describe the components of GraphRag? And then can you describe how you handle identity and access to information?
I mean, it is, I guess, easier, to be honest. There's a couple of solutions that what we implemented, so what we're currently working on is the following. Imagine that you have documents, and imagine that a particular user comes, okay? We map the user to the basic authentication, so he has a particular UI, let's assume. I enter the system, and there are some documents that are masked for a user like me who doesn't have access to those data points. So if a retrieval or retriever function has this information, then those documents will not be retrieved. Even if they are retrieved, for example, you ask a question, where is the capital, or which city is the capital city of Germany? Mm-hmm. If for myself, if this fact exists and it's masked, even if it's ranked in the top level, basically the LLM, this information will not be passed on to the large language model. That will be the easiest way, or maybe the naive way of implementing basically this idea, so that user cannot, or there won't be any information leaked to a user who doesn't have the proper rights. Mm-hmm. That will be, there are plenty of ways, but I guess that will be the one option. Or one could apply the following. If a particular entity belongs to a particular class, then this user will not be seeing any instance of that particular class. That will be one of basically a clustered session of limiting the access. But there are plenty, I guess.
Yeah, I think it's basically standard digital rights management. I don't really think that doing RAG changes the problem in a particular way, or basically in a very specific way. The only area where I would see some changes would be entailment. So if you have to run entailments to actually do the rights management, because your entailments, for example, are expressed as some OWL constraints or the like, then life becomes rather difficult. But then if you take a very expressive description logic language, it makes the life so difficult at scale that I would refrain from doing so. So it seems to me that basically one should stick to standard rights management. Dean, do you have a different opinion on the subject matter?
Oh, I'm sorry, I was looking up the woman who is doing the embedding work. Her name is Ellison Ann Williams, and she's a founder of a company called Enveil, which is where they use this technology. And the reason you saw me sort of snort and giggle is that she's in Baltimore. She's right here. I could actually have lunch with her. So I'm sorry, because I was tracking that down. But actually, I was thinking the same thing, in the half of my brain that was still listening, that a lot of this is plain old digital rights management. But there's this issue on the edge of, so if I am able to see this, how do I make sure that there isn't somebody who's snooping who can see that? But that's actually not a new problem, and it's not specific to RAG, and it's not specific to LLMs and so on. And it's not like it's not a problem. It's just that a problem that I don't think that the LLMs and RAG have actually added any extra challenges to. That was challenging enough as it was. The idea of sending embedding stuff through, so that even if you crack the system, you can't gain anything, which is what Unveil is up to. But let's imagine that Unveil doesn't have their solution yet. They don't, and it doesn't work. Then yeah, you're just gonna have to do the usual stuff. And then these weird use cases like the one that I outlined, where you actually need to be able to look over each other's shoulder, that's still going to be a puzzle. But again, being the fact that it was RAG or an LLM didn't change that equation.
So what do you think are the trends that you see pertaining to the use of LLMs and knowledge graphs? So you basically have an active company which uses those technologies. What would you say are kind of, on the one hand, the showstoppers, and on the other hand, the major benefits?
Shall I start, or do you want to start this one, Caglar?
Yeah, please.
Okay. Well, this question for me splits into two pieces right away. One is in the sort of everyday world, your social friends and family who are running into AI everywhere they turn. But one of the things that for better or worse, that I've been doing as an ordinary individual is that on my phone, I get an ad for some AI-powered app to do something. I don't download and buy every one, but I read through what they're doing. What are people marketing to individuals that are AI powered? I want to understand what that market is settling into. What are the things that are surviving and what are the things that aren't? And every once in a while, there's something seems to be doing, saying, "Oh, I have not seen anyone do that yet." I actually will invest $20 into downloading that thing and playing around with it. And sometimes it's like after 1 week, it's like, you got to be kidding me. These guys will be bankrupted as soon as their runway runs out. This is useless. And others like, okay, I might figure out how to use this. So I think that market is settling out, and I do try to watch it, not so much by reading the news, but forming my own opinions. Go and actually read these. How is this marketing to me? And what do they think of me, and what are they trying to sell to me? So there's that whole story, and I think it's going to be fascinating to watch how that shakes out. Because I also see amongst my own social circles, and I've now got to the point where I don't talk about my work in social circles anymore. AI is evil. This is where that pendulum is right now. You do AI, are you siding with the billionaires who want to destroy the world? And this hyperbole is, I'm not making that up. I've got personal friends who post things on Facebook that are like that. So it's like, I really don't want to spend my time fighting with people about why I'm doing AI. And it's like, by the way, I've been doing AI for 40 years and you didn't complain about it until now. Now, then there's the business side. And this I also find fascinating. Of course, here I'm actually participating in this, and partly because I work for a company whose main product is a data catalog. But there's a reason I work for that company. I chose to work for Data.World 3 years ago, is because I really do think that data is still king. And if you have garbage in, garbage out has not changed. The LLMs haven't changed that formula either. And that I think that all the stuff that we've talked about in AI for my whole career, the last 40 years, of why knowledge is important, why formal representation of knowledge is important, why knowledge sharing is important, all these questions that Axel or Alexander asked about how do you do identity resolution on a distributed scale. These are questions that we've been worrying about and finding interesting approaches to for a long time. And in some sense, what the AIs are doing is making the value of doing those things more readily apparent. So, gee, if we had all that identity stuff, I could write queries easier. I'm sorry, what were you saying? If we have all those identity things, I can suddenly have an understanding of all of my corporate data, despite the fact that it's terabytes of data and literally thousands of distinct databases and tens of millions of data entities of one sort or another, tables, columns, joins, whatnot. And I've never had any understanding of what my data is about, and now I can. Whoa. Okay, now the value has, instead of getting a little bit of value for doing your knowledge work, the amount of work you're doing has not changed, but the value you get has gone way up. And so I'm seeing a lot of companies, our customers or our competitors and their customers, really seem to be saying, do I really need all the data I've got? Because if I do, I now have an ability to make use of it. If I was collecting data just because I sort of thought it was good to do it, but I never knew why, well, now I've got the rubber's meeting the road here. I now can get value out of this data, but I can't get value out of the data if I don't do something in my business with my data. So data has gotten hot because of all the things that AI has done with it. But just like the individual market, how is that going to shake out? Is it going to be chat with your data? Is it going to be data experiences that are not obviously AI backed, but they get you're led along a path by an AI, but you never know it? How is that going to shake out? It's really hard to say, but it's cool watching the market do this. Chat with your data is one that a lot of folks are interested in. That's what we're focusing on. But we also see Snowflake and IBM and Microsoft. A lot of folks are doing variations of this. And so I think that's going to be, sort of what the first entry into this. But that's not surprising. The whole world got excited because ChatGPT was so easy to use and easy to understand. Chat is a very compelling metaphor, but it's not necessarily durable. So we'll see how that goes.
I know initially I found that, I think we all saw on LinkedIn and other social platforms, people singing the praises and promises of ChatGPT and LLMs and generative AI and how it's advancing and it's not going to get any dumber. It's only going to get better and all these arguments. But on the other hand, I also saw the historically involved computer scientists such as, people in the semantic web sort of scoff and say, people are adopting these technologies that are just a blender of words. They're just digital parrots. And they hold no real value if you want to have precise meaning and be able to have non-trivial applications and ground things in factual information. But now I'm seeing that there's this merging of both where people are saying LLMs by themselves are useful, but they're not useful alone without being able to ground them into some sort of domain or some sort of knowledge representation layer. And then knowledge graphs are seeing the benefit of having something that can abstract some of the tedious work that was required previously to be done by hand. So I'm seeing that these things are merging, but I still see that there's a large technical gap in understanding how accessible or inaccessible implementing these technologies really are. Dean, as you said, there's a lot of companies that are still kind of alive only because they've had a ton of money pumped into them. So they appear to be useful and having a good presence commercially. But once the funding runs out, they're going to die and implode. And customers are going to be left with a sour taste in their mouth again, and we're going to see how the symbolic AI folk and the people that were employing LLMs responsibly in the right use cases are able to pick up the pieces and start bringing that into a mature adoption of the technology.
Well, funny you should say this, because about a year ago today, possibly, I was at the a conference called the Taxonomy Boot Camp, which was as part of KM World, and I was giving a keynote there. And my thesis of the keynote, your keynotes need to have a simple thesis, was you in this room. And remember, the room is filled with people who are called taxonomists. So these are people who do, enterprise data management, but particular terminology and the relationships there. I said, if any of you is avoiding doing AI, I remember it was a year ago, so AI was still a bit new, avoiding doing AI for any of these reasons, I have a slide with a whole bunch of reasons that people don't do AI. I said, you need to get off of the slide because AI needs you. It's all going to, basically what you just said, it's all going to come crashing down when we realize that wonderful, I think digital parrots is actually a misleading metaphor, but we can talk about that later on. That all of this stuff, it's wonderful, it's doing cool things. And at some point, people are going to say, but gee, we need to make sure that we're talking the same language as this thing. It's actually kind of obvious that we're going to need this stuff. But in 1 year's time, or not necessarily, in a few years' time, the AI folks are going to be pounding on your door saying, how can I organize my terminology? I've got this amazing thing that can take language in, language out, find all these connections here. But if I don't know what word you use, I can't talk to you. How do I? And then they're going to realize that needs to be managed. And they're going to say, I never thought of actually managing terminology. Who would ever think of doing that? It's like, the boot camp folks are thinking of that and have been for a while. So you guys need to be ready, and not just for your own sake, for the world's sake. They're going to need your help, and otherwise this technology is going to run amok. And that was the thesis of my talk. Like, you guys need to be ready, because you're going to be in the spotlight real soon, because you're going to be needed.
Who knew that the mathematicians and librarians would be inheriting the world of AI?
But they really are the fathers of AI, partially at least.
Yeah, I'm going to say, what do you mean inheriting? We're the ones who had it at the beginning.
No, I know. But I'm saying it's coming all full circle, you know.
Now, finally, back to where it started.
Where it belongs. Yeah.
Thank you, Axel. Yeah.
Cool.
What about you guys? What about you guys? What have you been seeing in terms of adoption and industry trends? I know you guys are implementing Tentris in several projects. What is sort of the temperature in the room for how much people want it, and the challenges in implementing it, and some of the opportunities that you see now that you're getting out there in the world?
I think there are basically two major questions, at least within the German-speaking world. One of them is really, can we go beyond Sparkle? Sparkle is great, no question. We can write queries, but there are like those 5 people who know how to write Sparkle, right? And then in the company, if you have a knowledge graph, you basically want everybody to be able to use the data. Mm-hmm. So, and there again, you have 2 sub-branches. One is the very data aficionado who's like, I want to not only be able to query my knowledge graph, but actually query everything that I have. Mm-hmm. With really one language. And that's what I was talking about before. So basically, one direction which we're going is really having these more hybrid versions of Sparkle that do more than just Sparkle, and that can actually talk to an LLM or to a vector database or whatever other sources are out there to actually enrich the answer. That's the one side. And basically, the other side is GraphRag. GraphRag really seems to be something that where companies finally understand, I would need to talk to everything that is in my company, and I need a way to unify the meaning of that data so as to be able to talk to it. So having this layer, I mean, we've been saying semantic layer for, 15, 20 years now, or even longer. But now we're there where companies
showing your youth, Axel.
What?
Showing your youth, Axel. There were these things called semantic nets. I mean, now I'm too young for this. The semantic nets back in the 50s.
John Sowell, right? And
exactly. They were talking about this stuff in 58. So yeah, that goes back. That even is too old for me. So
yeah, but we've been talking about those things forever. I mean, we knew that we needed them, but that was basically more the researchy part of things. And finally, companies see, okay, this is really needed. And we really see this trend coming up, basically saying, I have all of that data. My knowledge is in there. How do I put that together? And that's something we're super interested in, of course, basically building that layer and making it easy to build that layer so that we can actually now apply these very, very nice querying techniques on top of all that. So those are the 2 major trends.
Well, I'd put a third one in that. I mean, the way that those of us who come from a virtualization world look at this is that the connect to anything is a virtualization problem. And virtualization has been around for not quite as long as semantic layer, but for a long time. So if I want to talk to any of those resources you're talking about, shove that into the virtualization layer. Now, the beauty of that is we already have our universal language. We already have our universal modeling language. That stuff's all done. Of course, the downside is now you've got this puzzle. How do you actually build all those mappings to the virtualization mappings to the rest of the world there? And that's another way to, it's pay me now or pay me later. I'm not sure which one's now or later. You've got to pay the price somewhere along the line, and you can do the price up by making the query language souped up, like you were talking about, or you can keep the query language stable and soup up the virtualization. And where do you pay the price? I reckon it's probably going to wind up, you're going to have an entire stack and you pay the price wherever your money happens to be closest to. Like Caglar was saying, he's an engineer. He doesn't do things because of some principle. He does them because they're easy and effective. And I think that's eventually going to become the driving purpose here. There's this whole stack, and if it's easy to do virtualization, like relational, that is understood extremely well. But virtualizing into a streaming JSON stream, it's going to be a bit more difficult. Maybe it would be better to have a specialized query language for that kind of thing.
Cool. But that basically brings about the question, at least to me, should we build in semantics into LLMs? What's your take on that? Semantics in the sense of formal semantics.
I've been talking a lot, so I'll let somebody else talk first.
In the sense, Demir, Joaquin, Dean.
I believe in end-to-end differentiability, and semantics would not work, at least to my mathematical knowledge. It is very beautiful. I wish that someone in the whole world, someone would come up with it. But so it is very hard to differentiate through the semantics, which is inherently structured. It's basically binary. And it's not continuous.
I don't think I'm fully qualified to answer this question because I don't have nearly enough practical or theoretical experience in this space. But what would be really cool is if, in the same way that there's a marketplace where you can download different versions of LLMs, you could download plug-in semantic platforms or something that complements a particular domain. So rather than doing fine tuning for LLMs or whatever, you can complement both and say, oh, here's an open source ontology on biomedical information, and here's a general purpose LLM. I can just download them and plug them together, and now I can start to query and see what's true, what's false, and where do I fortify this.
But of course,
that's really nice. Yeah.
These generative AIs do have an architecture for doing that. It's called LoRa. You usually think of LoRa's in the image space, where the AI image hobbyists have an amazing architecture for this stuff. You can go up to Civet AI and download any of 1,000 LoRa's that you can drop in. And a LoRa is a low rank adapter, I think is what it stands for. And then it's exactly that. It's a plug-in to your model. And the same architecture works in the LLMs. You just don't hear about it as much because it's not quite as exciting as it is in the images. So that sort of thing is at least architecturally possible. But I'm not sure that I want that. And it comes back down to explainability and trust. If I'm going to go off to a biomedical data source, the fact that glyphosate has a phosphate group, do I want to train that into my LLM, or do I want to have a database that says, hey, here are the groups of glyphosate? Now, you might have some training where at least knows where to go and find that sort of stuff, but I'm not sure that's going to be that helpful. I really want that factual stuff and a lot of that reasoning stuff to be in a system that knows how to deal with facts and reasoning. And we've got a lot of those, right? You don't have to use the semantic web stack if you don't want to. There's reasons why I have some prejudice towards that, but that to do your reasoning in a system where you can actually trace the reasoning, and then what does that leave for the LLM to do? Well, things like figuring out what somebody meant, figuring out how that maps into those things. And it's actually, the LLMs are good at all that fuzzy stuff. I feel it's kind of a render under Caesar. I don't want to keep the biology out of the LLMs. I mean, I'm not gatekeeping, but I'm not so sure that they want it or they're going to be able to make much use of it. Whereas our knowledge graphs actually can make a lot of use of that, and we actually understand how, which is kind of the point of the talk that I gave 2 hours ago, that you have this thing that's completely explainable, and the LLM can help you build that. But once you build it, the explanation is independent of where it came from. We can't trust the LLMs to explain themselves or even get the right answer. But if we have an answer we can validate, great, you gave me the right answer. Now, it's often more difficult to generate an answer than to determine that an answer is right. And the LLMs can actually shortcut you through a lot of that.
Cool. Well, solid answers. It's quite interesting how they're not far apart, but basically the functional assumptions that are made in the two answers are quite different. I think I would see myself in the middle, really. I think there are things that we can train into an LLM, as long as we go beyond LLMs. So the whole idea of an LLM is really having differentiable distributional semantics. And the question is, do we really have to make that assumption? Or is there a way really to say, no, we are going to really look at separate between crisp and non-crisp, but still put it within the same framework? Unfortunately, how that would work, but it would be quite interesting to try.
Well, there's a framework that I learned about this week that the folks at RPI are doing with Deb McGinnis and her group, where you've got an LLM, but it's part of a larger learning architecture. And so there's some vector database in there. I haven't seen the details of it, but one of her colleagues was in a working group that I was in yesterday. And like you said, it has to go beyond an LLM. There's an architecture that has LLMs in it, but other things in it that we're more familiar with, things like knowledge graphs, things like vector databases. And the architecture has been put together in such a way that this whole box is the thing that you train, and parts of that box train like an LLM, this very fuzzy, inexplicable thing. Other parts of it, train like you train a textbook. You actually write down facts and organize them into a structure. And some other stuff about how like the vector database kind of goes in between those things, there's little RAG structures inside and so on. So the advantage of what they've put together and how they measure, is this architecture working or not, is all of the training affordances that the overall architecture gives. So it's not an LLM, it's this bigger architecture. And in my slides an hour ago, I actually made a change literally 5 minutes before. All of those little agents in there I had labeled as AI, and I changed it to LLM because I really want to say I'm talking about a very particular kind of AI that has certain powers and certain weaknesses. If I'd put AI in there, thinking about what Deb is doing, well, that thing could actually have a whole knowledge graph living inside of it because it's a more not a fully general AI, but a more general AI. Everything I was talking about was capabilities and weaknesses of a very specific approach, which is LLM. And I think you're right. If you go beyond that, and that's exactly what the RPI folks are doing, then you can have other affordances for talking to this thing. And by talking to it, I really mean training it.
No, cool, totally. So that would basically be this mix of crisp and non-crisp. I mean, there are other ways to do that, right? By basically triggering. I don't know if you've seen these adaptive RAG scenarios where you always have a judge, and the judge basically decides what to do next. And one could actually think of a larger AI type system, basically with gates. It's also the case when you use a mixture of experts. You also have these gating type properties where you really decide which part of the net to use. Well, you could basically pull that out and actually shove a knowledge graph in there. So totally, I do totally think that that's actually the direction which we should go, because there are things, as Damien mentioned, which are not differentiable. And we also shouldn't press them then into a differentiable world, but rather use the toolage that we already have.
Absolutely. So I want to maybe one anecdote here. So my humble opinion, so this maybe is a little bit controversial, but instead of using large language models as a decision maker, maybe they are a decision helper. What I exactly mean by it? So I'm a programmer in the last, many years. So, and these days, I know where to write one particular program in one particular language, and I can spend half an hour or 10 minutes to write it down. But I can use the LLM or vendors, basically, OpenAI or Anthropic, as an external, not only memory, but external part of my brain that I can take the data from there by prompting them. For instance, I would like to write let's say Python function. I add the to-dos here. I would like to write this, I would like to write that, and this will be a PyTorch, this will be NumPy, so store this one to the CSV file. If you describe this, they do incredibly well job, and I have been using them, and it's for free. So I cannot imagine that when I was a child, I wish I had this opportunity. Now, these amazing tools can help you in many ways. And obviously, you can expect them to know one particular disease. But do we really if you talk to the doctors, like medicine, so I don't think that they would say that they have particular reasoning. They know obviously well, and if something goes bad, they take responsibility. But why don't we use these amazing, powerful tools as a helper? Hey, I guess these symptoms can mean this. So what do you think about it? And maybe prompting a medicine, basically. Other way around. Patient comes and tells some stuff. And the large language model-like system takes this input and then suggests maybe, hey, these symptoms likely to lead to this or be caused by that particular disease. And then the doctor or our medicine then make an informed decision, and either can reject. By reject, you can basically feedback loop or accept or maybe modify. So that would be my take on this topic.
So Zach Kahana wrote a book very early in the new AI revolution. I remember reading it in June of 23. I'm looking it up here. It's called The AI Revolution in Medicine, GPT-4 and Beyond. And he wrote it very early, and that he actually got a preview of GPT-4 before it was available to the public, because he's the chairman of the Harvard Medical Library and got an in with OpenAI to do that. And he and his colleagues were following along exactly with very early AI. I mean, everyone in this room knows more about AI than Zach did in June of 23, because nobody knew very much about it then, but he's following along exactly those ways. So he's actually a clinical physician. He does his rounds, then he goes home and talks about intelligent data management in medical records in the world. That's what he's done his whole career on, but he still has his rounds. He's still the clinical practitioner, and he was going down exactly the road you're going here. How does an LLM enhance what the physician can do while they're actually doing that physician work, sitting in front of a patient, doing the rounds, and exactly the example that you gave.
I think it's complicated enough just talking about the technology itself to weave in the human technical broader.
But Zach doesn't do things because they're easy. He has always been somebody to sort of take problems by the horn and wrestle them down.
Last week, I was running a panel discussion with 3 industry experts from various places. One of them works for a company that works to do data annotation at scale with organizations for fine-tuning and improving LLMs. Another one is commercializing a clinical helper. So a doctor can look up a disease or look up a medication and be able to traverse adjacent facts to that to be able to provide richer information to a patient at the service point. And then another one has been in the mental health space for some time, and he actually created a machine learning expert-driven system that helped to diagnose or provide a likelihood of diagnosis around patients, because usually I think it would be psychiatrists, the people that prescribe medication. They have their procedures to go down, but there's a severe lack of psychiatrists in practice. So this was meant to sort of augment their capabilities to service more people at one time by not having to worry so much about diagnosis, but complement their diagnosis procedures. But the point of the whole thing is, we were talking about that there's this wide gap between young doctors and really seasoned doctors. Really seasoned doctors wanted to break the tool. They wanted to compare the responses and the queries against their 20 years experience of doing what they've done. So they have super huge confidence into their domain expertise, but they weren't really sure about the what this machine, what this AI can provide them. And then on the other side, the young doctors, the residents, they were becoming dependent on the technology, and they trusted the technology because they didn't have the confidence or experience to be able to differentiate what they were able to do. But at any point, there are anomalies, there are freak incidents, there are undiagnosed bacteria that come out of left field. So I don't know, in practice, this is a much broader conversation that I would love to continue in, but yeah, as long as you can explain the reasoning, as Dean was saying, I think that's the basis for being able to interrogate the truthfulness of that response, right?
And actually, going along with something that Caglar was saying a moment ago about programming, I've become a much more productive programmer in languages I didn't know very well, say 2 years ago, and Python being one of them. And when I mentioned a year and a half ago to someone, I let Python write this cool program that I've always wanted to write, it would have taken me days to do this, and I finished it in an hour. I said, but how do you know it's right? All the same ways that I knew it was right before. I have test cases, I have regressions. I am a software engineer. Remember, I actually, and software engineers don't just write programs and pretend they work. No, I actually know what kind of failure modes are common. I know how to test for them. I know how to read code, and they, oh, wait a minute. And I would even go to the LLM and say, at this line, what happens if this data structure is null? Oh, it's going to fail. Yeah, it is, isn't it? Could you please put a check in to make sure of that and do a soft fail? Oh, sure, I can do that. How did I know to look there? And how did I know that a null for that data structure is a common failure? Because I have decades of experience with programming in lots of languages, and that's a universal problem. And when I pointed out, it would have taken me 15 or 20 minutes to figure out where to put the check, what the check should be, where I should put it around and rearrange the loops and so on. The LLM did it right away. Yeah, I still needed to bring in the smarts to know what to look for, but the LLM was able to deal with it. And then I could look through and run my test. Okay, I created a test that tickled it. That doesn't tickle it anymore. So how do I know it works? The same way I always did, through testing and regressions and all this kind of stuff and reading the code. It just, I don't have to spend as much time doing the grunge work of redoing loops and getting all, and then Python, the encodings, when you pass something off to an HTTP call, how do you encode the thing and how do you decode the thing and comes back? I would spend hours trying to get that right. And I just say, get the encoding right first time, every time. It's like, okay, you just saved me 2 hours. I've never got those encodings right the first time. And this is how I've convinced skeptics who say, oh, I don't want to do this. I'm a good programmer. And it's like, do you enjoy spending an hour and a half on encodings? Oh, encodings. Yeah, I have that problem. Yeah, not anymore. You don't have that problem anymore. Oh, maybe I should look into this. Yeah, that's how I've convinced a lot of folks. Just, it's the stupid stuff. How much time do you spend on stupid stuff? You probably don't know because your mind goes numb. I spend a lot less time on stupid stuff now. Anyway, I'm afraid we're taking you over your time, Joaquin.
No, it's cool. So yeah, but I think we're slightly past the time allocated. I would like to thank you all, first of all, for participating. That was really cool.
Yeah, this has been a blast. Thank you, everybody, for this.
Yes, indeed. So
Joaquin, for organizing all this stuff and creating this swarm community. This is going to be wonderful.
It's really, really cool. Yeah, I highly appreciate it. I think we learned a lot about GraphRag, what it is and what it isn't. We still don't know what it is exactly, but we'll work on that. And the whole idea of going beyond LLM and putting basically this distributional semantics and basically crisp semantics together. I think it's a challenge we're still going to be dealing with quite a bit, but I think we've basically taken a step in that direction. Thank you all for joining and participating, and see you soon.
Okay.
And if you have approximately 30 minutes, join the networking and meet somebody new.
Yeah, for sure.
All right. Well,
cheers.